Hi, everyone. For those of you who've just joined us, welcome to CPD Live. We're running the session entitled Specifying Bathroom Fixtures for Hospitals, Meeting the Infectious Disease Challenge. My name is Alice Blackwood. I'm your moderator, and today we'll be joined by presenters Gavin Atkinson, who works as the Business Development Manager for Commercial New South Wales with GWA, and Nick Swan, who's our Senior Portfolio Manager for Care and Commercial with GWA. We're just waiting for everyone to join us, and then we'll kick off this session. Thanks for joining us all today. All right, I've had the go ahead. We'll be kicking off in just about 10 seconds time. All right, I think it's safe to start. So, as I mentioned, welcome to CPD Live. I'm Alice Blackwood. It's my pleasure to be facilitating this discussion, which focuses on the specification of bathroom fixtures in healthcare settings. Before we begin, in the spirit of reconciliation, InDesign Media acknowledges the traditional custodians of country throughout Australia and their connections to land, sea, and community. We pay our respect to their elders past and present, and extend that respect to all Aboriginal and Torres Strait Islander peoples today. And now to today's discussion. Despite the best efforts of healthcare professionals, hospitals are not always the best places for sick people to be. Each year in Australia, around 165,000 patients contract healthcare-associated infections while in healthcare facilities. This session focuses on the way the well-considered specification of bathroom fixtures can help address this problem. Our speakers will examine the products and design approaches that can help minimise the spread of infectious diseases in hospitals. So, by the end of this session, you should be able to, 1, outline the prevalence of infectious diseases in hospitals and other healthcare environments, as well as their causes. Identify design practices and sanitary ware products that can help minimise the spread of these diseases and therefore improve patient care. Outline the regulatory requirements associated with healthcare environments and identify sanitary ware products that help meet these requirements. And finally, explore options for furniture, fixtures, and equipment product specification within hospitals and healthcare environments. So just a little bit about today's session. We're going to start with a 40-minute presentation, followed by about 20 minutes of question and answer time. If you would like to ask our speaker a question, please send a text through the Q&A field at the bottom of your screen. So to introduce our speakers, we're joined by Gavin Atkinson, who is the Business Development Manager for Commercial New South Wales with GWA. Hi, Gavin.
Hi, how are you going, Alice?
Really good, thank you.
Fantastic.
We're also joined by Nick Swan, who's the Senior Portfolio Manager for Care and Commercial with GWA. Hi, Nick.
Hey, guys.
And so I'm going to stop talking now and hand over to Gavin, who's going to take us into the presentation. Firstly, Gavin, could you tell us a little bit about Caroma? What does your business do? Who are your clients? And considering our topic today, tell us a little bit about your work in the healthcare sector and take us into your presentation.
No problem at all. Thanks for that, Alice. Appreciate the introduction. Firstly, hi, everyone, and thanks very much for joining us today. It's a time out of your day, and we certainly appreciate it, and we hope you get a lot out of today. As Alice said, I'm Gavin, and Nick will be joining us a little bit later on to answer any questions you may have during the Q&A part of the process. I suppose a little bit about myself just to start off with. I'm 20 years previously in the commercial refurbishment space, working within such facilities as certainly hospitals, health-related facilities, retirement villages, aged care, and other commercial properties. I held a number of different roles in that time. In those 22 years, you can imagine there's a few different roles, including estimating, project management, sales management, and finally state management responsibilities. I think if I look back on it in relation to the hospital space, the experience of working within operating facilities, that is running hospitals, running aged care facilities and the like, I think it gave me first-hand experience and insight into the vulnerable nature that patients are in or experiencing when within a hospital environment, and certainly obviously their family as well. So it really highlighted the importance of I suppose the cohesion between the built environment and the level of personal care provided by the staff, and how that works together in a seamless fashion to provide the maximum healthcare benefits for the patient, whilst maintaining their dignity. And I think I've taken that experience gained around the FF&E being an integral part of the care solution for a hospital in my current role at Caroma. I've been with Caroma now for 3 years, 3 good years. And it really is about, I suppose, understanding that the FF&E has a vital role to play in providing for that exceptional level of patient care whilst maintaining their dignity, and of course the broader health aspects. A little bit on Caroma, very quickly. Caroma was established in 1941 and has grown to be Australia's largest provider of sanitary, tapware, basins, showers, bars, accessories, and smart fittings and fixtures, as well as sensor technology. I think the important distinction here is that we're a provider of all these products, and all of these products are designed and tested in Australia for Australians in Australian conditions. And I think that's a really important distinction to note. In fact, the Caroma started with the innovation of the first one-piece system way back, and that was to avoid the corrosion due to the water in Adelaide, in Australia. And I suppose it's this commitment to innovation, reliability, and certainly sustainability that drove the beginnings of GWA and Caroma, and still drives us to this very day. And I'll touch on that briefly just in a moment. So moving into the presentation, guys. So welcome to GWA, a business with purpose. A couple of brands there: Caroma, Clark, Methven, and Dorth, that I'm sure you're all well aware of. Caroma, aim to make life better through design and delivery of products and technologies that create superior solutions for people to enjoy and sustain water, our planet's most precious resource. Sorry, I'm just having a few technical difficulties here. And we are a world of products, guys. We are not just a sanitary ware where this business started, and I suppose we're extremely well known for. We have a broad range of complete bathroom solutions, ranging from tapware, showers, basins, bars, accessories, kitchen sinks and tapware, grab rails, whether they be load rated to the 110 kilos or AS 1428 compliant, AS 1428 compliant ambulant products, independent living, and smart fixtures and sensor tapware. I touched on the history of innovation, and I'm not going to go through every item here, guys, but starting in 1980 through to 2005 with the invention of the world's first dual flush system. So it started 11 litres and 5.5 litres for a half flush, and it's been I suppose, continued to evolve through that process in 1993 to 2005, where we end on the 4.5 litre full flush and 3 litre half flush. The reason why I note this, guys, is this saves the equivalent of the Sydney Harbour in fresh water for Australians each and every year. And obviously, as the population grows, the effect of this will only grow with it. So it's certainly a story of innovation that results in sustainability. The important thing for Caroma during this process was to ensure that the flush mechanism still had that very strong flush, efficient flush that Caroma is synonymous with. So it's not just about sustainability, it's about how do we innovate and maintain that high level of quality and reliability. Moving on then to the first Wells 6-star urinal, and then fast forwarding right to 2016 and 2018 with the development of the Caroma Clean Flush technology, truly rimless technology that allows for the bowl to be more properly cleaned, whilst once again maintaining that great flushing experience and efficient flush that I suppose Caroma is so well known for, and is so important actually within the hospital environment as well in terms of bacterial prevention and the like. And then moving on to 2018 with the development of our Smart Command technology, which is both touchless and allows for the collection and collation of data that relates to the usage patterns of those particular items. Centre of Innovation, and I touched on this earlier, all Caroma products are designed and tested in Australia for Australian conditions, and that's really, really important. And I think a real contributing factor to the reliability and quality that Caroma is known for. So we have one here in Sydney, located at Preston's, and the other one in New Zealand, where it really allows for new product development, but also the testing of the existing products and the continual refinement of. Moving on to the presentation. Today we're going to go through infectious diseases in healthcare environments, sanitary requirements of common hospital areas, basins, and sensor tapware and smart fixtures. Infectious diseases in healthcare environments. Infectious diseases in healthcare environments. Now, there are three types of infectious diseases involved, and we're going to consider each of these separately, but it might be worth noting down each of these three. They're waterborne infections, viruses, and bacterial infections. So just to note down, waterborne infections, viruses, and bacterial infections, and we'll run through each of these. Waterborne infections, transmission via consumption of contaminated water, or the inhalation of aerosols from aerated taps and showers. Most common waterborne organisms include, once again, guys, these are probably pretty important. You might want to note these down: Legionella bacteria, Mycobacteria, and Pseudomonas. So most common waterborne organisms include Legionella bacteria, Mycobacteria, and Pseudomonas. Waterborne infections, now the methods of prevention. Thermostat of hot water systems should be set to high. Tempered water lines regularly flushed with hot water in excess of 70 degrees Celsius. Laminar flow aerators can be specified for tapware to remove air from the water stream. And aerators can include antimicrobial protection to kill the bacteria itself. So virus or bacteria. Now, non-medical people tend to sometimes confuse them, but viruses and bacteria are fundamentally different. And it's certainly worth noting the difference between the two, once again, being important. So bacteria are single complex cell organisms which can survive on their own inside or outside of the body. Viruses, on the other hand, are not cells and need a host, i.e. us or an animal, to enter a healthy cell and multiply. So bacteria are single complex cell organisms which can survive on their own inside or outside the body, and viruses are not cells and need a host, human or animal, to enter a healthy cell and multiply. On to viruses. Well-known examples include influenza, of course, and COVID-19, that we all know the story of COVID-19 over the last 3 or so years. All viruses behave differently and transmission varies from virus to virus. Common methods of transmission include ingestion of airborne droplets or particles expelled by coughs, sneezing, or breathing, or by shedding skin, or by touching surfaces themselves. Methods of risk reduction: social distancing, isolation, personal protective equipment or PPE, all the things we're used to dealing with for the last 3 years, guys. Development of vaccines, thorough cleaning regimes, specification of non-porous surfaces, and sensor-operated technology on shared touch points to reduce that need to touch. Moving on to bacterial infections. Transmission can either be via air droplets, food, or there are other infectious people or persons, but most common is by touching a contaminated surface. The most serious of these, known as superbugs, include E. coli, Klebsiella pneumoniae, and Staphylococcus aureus. Now, arising as a result of antibiotic resistance, superbugs are estimated to kill approximately 1,000 Australians each and every year. And that's from the Antimicrobial Resistance Impact Report dated 2022. Bacterial infections, methods of risk reduction, good personal hygiene amongst patients, visitors and staff, regular washing of hands and so forth, strict cleaning regimes, fit for purpose surfaces that are virtually non-porous, designed to minimise cracks and places bacteria can live and breed. And once again, sensor operated technology on shared touch points to reduce that need to touch. Antimicrobial surfaces. Antimicrobial surfaces may inhibit the growth of microorganisms. They can be incorporated into sanitary ware, basins, tapware, flooring, grab rails, and all touch points. For best results, use products rated to 99% antimicrobial protection. And it's important to note that common test methods used to rate antimicrobial product resistance only assess certain bacteria such as E. coli and staph. In some cases, it is possible some strains can develop a resistance to this process. Sanitary requirements of common hospital areas. The potential for infectious disease transmission varies according to the type of space and its application. These areas can be divided into 4 categories. Firstly, patient rooms, staff wash areas, public areas, and other areas. In turn, patient rooms can be divided into 3 different types as well. Your standard room. Now, they're certainly likely to have care features, grab rails, drop-down rails, a raised toilet, etc., but aren't required to meet AS 1428. You might want to consider toilet aid use, e.g. commode chairs and circulation space, how it's going to work in the space and so on, and shower chairs as well. High care rooms. Areas where hoists and heavy equipment will be used to assist in toileting and showering the patient. Basins with increased load-bearing capacity are required, and they're likely to include full care bathrooms. Mental health rooms. Now, these are patients vulnerable to self-harm. Fixtures should be as integrated as possible. Anti-ligature items are recommended. Basins with increased load-bearing capacity, enclosed or integrated traps. Staff wash areas. Similar to patient rooms, there are various types of staff wash areas, each with their own requirements. You have the clinical scrub, nurses' stations, staff change areas, and procedural / consult rooms. So clinical scrub. Now, these are for minor clinical procedures, not to be confused with surgical scrub. These are used for catheter inserts, sutures, delivery suites. Nurse stations, corridor hand washing bays used by nurses for washing and sterilisation between each patient contact, I should say. Procedural consult room, wash up after specimen collection. Now, some specific consult rooms have their own standard. Please refer to the Australasian Health Facility Guidelines, AHFG, for further detail on that. And then you have your staff change areas, showers and bathrooms. Public areas. The public areas can include obviously your public toilets, accessible toilets, change rooms, showers, and other public areas. Public toilets. Now, they're a standard bathroom offering. Ambulance compliant toilets are recommended, i.e. easy height and the like. But once again, moving back to, you have more flexibility there. They are a standard bathroom offer. Accessible toilets. Now, every specification for a hospital should have an accessible AS 1428.1 offer included for the common areas. Once again, not required for the patient room. Other areas, the various other areas in healthcare environment to be considered in terms of infectious disease control include cleaner or janitor closets, staff breakout, cafe/kitchens, and research clinics or labs. Public areas, public change and showers, sometimes tied up in procedural rooms, similar to X-ray or radiology spaces, but more for the patient visitor use than the actual staff on site. Moving on to bariatric needs. Bariatric refers to the treatment of obesity. Patients likely to be craned and hoisted in bathrooms, in-wall cistern options that provides more space for your carers and assists with the general cleaning of the area as well. Basins available with optional bariatric rated bracketing systems are certainly recommended. Bariatric loading for toilet seats with maximum load requirements at 4 kilonewtons, approximately 400 kilograms. Moving on to basins. A basin design should have the following features: have no overflow, have curved sides to minimize splashing, minimize flat surfaces to avoid water pooling, are large enough to enable good hand hygiene techniques, are sealed to the wall or far enough away from the wall to allow for effective cleaning, and have a waterproof splashback, once again for effective cleaning. Basin design, hand basins continued. The hand basins should be paired with suitable taps. Integrated plugs should not be included. Water suitable temperature for hand washing under running water, made of hard, non-scratch material and be easy to clean. Polycarbonate or other molded plastic materials are not suitable. Drainage design should be easy to access internally and externally and coated with an antimicrobial protection. Type A clinical basins. Required in selected areas requiring clinical hand washing, to be used prior to undertaking selected procedures that may occur in non-operating room settings, e.g. a delivery room. The basin is a large wall-mounted basin used with hands-free taps, elbow taps, foot knee operation, or electronic sensor taps with warm and cold water delivered by a common spout. Tap placement should allow washing up to the elbow. Refer to the AHFG to stay up to date with any changes to this standard. Type A tapware bottom right, as you can see there, suitable for use with a Type A basin, staff and public areas. Type B basins, slightly smaller than Type A basins, to be used in areas requiring hygiene, by staff and visitors for patient care situations and aseptic procedures. The basin is a medium, once again, wall-mounted type. The taps may be either wall-mounted or basin-mounted, with elbow or wrist hands-free operation and warm, cold, free running water. Once again, refer to the AHFG to stay up to date with any changes to that standard. Type B suitable tapware, as you can see there on the right, for use with Type B basins, staff and public areas. Sensor tapware and smart fixtures. Once again, moving on from, as we've heard earlier, the potential advantages in sensor tapware and providing fewer touch points for people within the hospital environment. Smart fixtures in healthcare environments. With the latest in data-driven management solutions, touchless taps, modern access systems and smart fixtures, it is possible to create an integrated bathroom ecosystem. This allows facility managers to monitor, analyse and measure information that may directly impact hygiene. Why use touchless sensor operated tapware for healthcare environments? And once again, these are all quite important, so I'd certainly suggest you maybe note down a couple at least. Firstly, boost hygiene compliance and improve efficiency. Access insights on cleanliness and hygiene, e.g. is the tap being operated every time a toilet has been flushed within a bathroom space. Identify fixtures and malfunctions. Observe behaviours and correct them through education. Reduce transmission of both bacteria and viruses. Automatic hygiene flush after periods of inactivity. So leveraging data-driven insights to optimise hygiene, monitor individual fixtures to preempt maintenance requirements, check usage of staff washing stations to ensure maximum hygiene standards are actually being upheld, leverage leak detection monitoring to minimise bacteria spreading, a leaking tap and the like. automatic flushing of tapware and toilets to keep surfaces clean. So that marks the end of the presentation. We now have the assessment. Alice, are you talking? I can't hear you.
Sorry, rookie mistake there. You think I would have learned by now. Thanks so much, Gavin. I've just been taking a few notes down, and I do encourage our audience as well to please send in some questions, because we've got lots of time for questions. So anything you're wondering about, drop a question into the Q&A panel at the bottom of your screen, because we can have Nick and Gavin respond to you. So Nick, you're coming in to conduct the Q&A with us as well. I thought maybe I'll just ask you, Nick, to tell us a little bit about yourself, your background and role with Caroma too, so we can understand that.
Yeah, absolutely. So I've been in the industry a little less time than Gav. I've been in the bathroom industry for 10 years, looking at bathroom fixtures across Caroma and Methven brands. So yeah, I look mostly at the care and commercial sector, and that involves, say, the product management side of things and the launching of GWA's innovative products across, say, hospital applications or aged care and commercial buildings. So that includes the smart technology products as well, and IoT solutions. So yeah, I've been doing the commercial side of things for about 4+ years now.
Mm-hmm. I'm fascinated because, Gavin, at the start of that presentation, you ran us through what some of the innovations are that Caroma's led with over decades. And there's obviously some deep knowledge here around hygiene, around how hospitals run, how those spaces are constructed and how they work. Like, how has Caroma gathered that knowledge over the years?
Look, I think you're certainly working with Australian standards would be one aspect, and working collaboratively with, and in certain instances even driving Australian standards. We spoke of our test facilities there at Preston's, which are industry leading and certainly there's nothing like it in the Southern Hemisphere. I'm not even sure about the world, but certainly the Southern Hemisphere. So that ability to test all products, test behind wall products, and understand how these products integrate it has been one aspect. And I think the other aspect is actually getting out there in the industry. I mentioned that I'm also involved in the retirement and aged care sector as well. And getting out there and talking with the developers, whether it be New South Wales Health or the retirement living operators and so forth, and understanding and certainly then talking to the people on site, the staff, the caregivers and understanding what are the frustrations around some products and how can we derive product innovation that assists the carers in providing a better level of care for whether it be the resident or the patient in this instance. And I think that's really fundamentally important. It sounds quite basic because when we get into the technical aspect of hydraulics and the like, but really if we start from a point of we're fundamentally here to improve the level of patient care.
Mm-hmm. And I don't want to put you on here with a hard question, and let me know if you need a few moments to think about it. But do you have like a good anecdote or case in point around where that practice of listening and really observing about developing needs has led to a product innovation for Caroma? And yeah, is there a particular example?
Well, certainly I don't want to talk. There's one that comes to mind. I don't want to talk too much about it because it's not out to market yet, Alice. But certainly,
tell us everything.
Good, juicy goss, hey. But no, look, certainly understanding toileting use, the style of chairs and so forth that are associated with assisting, whether it be in a hospital environment, commode chairs, whether it be in an aged care environment, once again, assisting the caregiver or indeed, the patient, once again, getting back to that point of dignity, and how do we maintain that patient dignity. So working with and designing and refining, I suppose, existing products to better work with the, existing assistive, equipment that I suppose is within the hospital environment.
I guess one of the genesises around the smart side of the business was, I guess, born out of a a realization that the plumbing industry is a little bit behind when it comes to smart products. I mean, in energy, like lighting, for example, it's been around forever. But for whatever reason, bathroom and water was just left to the side. So there was a need from a lot of the larger buildings who have got these fully smart systems, and then they've got these relatively dumb bathrooms for us to sort of play catch up. And that's kind of the genesis of why we got into the smart side of things. And it was to help buildings get a better understanding of how they use water. They typically know how much water goes in through the main meter at the front of the building, but they kind of just lose sight of it after that, and they can see how much waste comes out, but it's a bit of a black hole once the water comes into the building. So they were keen to get that deeper understanding of how water is used and how behaviours can evolve, and how people interact with fixtures. So it helps with understanding how people navigate through a bathroom, for example. What happens when you put dividers in next to urinals, or what happens when you place them in sight lines instead of toilets, for example. You just by doing some simple layout situations, we're able to save a whole bunch of water for buildings and help them achieve some of their sustainability goals. Because it's as you can kind of see on this slide here, flush volumes have kind of gotten as low as they can. So we went from 11 litres down to 4.5 for a full flush, and that's where they are right now. So we've kind of plateaued with the amount of water that we can save from a fixture. So buildings looking for these new ways to, what's the next step? How can they drive more efficiencies, and really it's a better understanding of how people use the fixtures and how that water behaves once it's within a building, to squeeze out every bit of efficiency that you can.
Can it support with hygiene insights as well? There was mention of the impacts that monitoring water use can have, but yeah, if you could run us through your thoughts on that.
Yeah, for sure. So with every single fixture within a bathroom being smart, you can obviously understand how many times people have used a sanitary ware fixture. Then you can also see how many times people have used tapware and for how long they have. So you can get correlations between the two and understand, do you have a positive or negative index with the amount of people who are using the bathroom and then washing their hands. So that's a really quick way that you can see how hygienic people are being within a given building. It also means you can use that data to funnel into cleaning schedules. So for example, you might just automatically just clean the entire bathroom at lunchtime or just after lunchtime, and that just might be the automatic process for cleaning staff. But if you knew that only 1 or 2 of those toilets was actually being used, then you've got a much more efficient way that you can deploy your cleaning staff to be more targeted, to only clean the things that have actually been used, and then you can spread them out and clean things faster, more efficiently, and potentially use less staff at the end of the day. So an easy one is understanding how much sanitary ware versus how many people wash their hands, but also duration as well. So how long are people washing their hands? Some people might just do a quick little rinse and think that's good enough. We can actually see how long people have been washing their hands for, and then we can provide that guidance back to the facility management team so they can start educating people or put signage up or however they want to combat whatever problem the data presents.
It's so interesting. And for our listeners, who I assume are all architects, where are the opportunities for them when they're designing healthcare projects and considering pushing their clients towards new innovation?
I think there's typically some very clinical looking products that are more functional, and they just do the job. And I guess there's a growing trend of us trying to make things serve the functional needs, but also aesthetically meet people's modern expectations of bathroom fixtures. So there's been a lot of work in the recent years to aesthetically upgrade how things look and make it feel like people aren't in an institution. There's something very hospital-like about a grab rail, for example, and there's these negative connotations about even just that, and sometimes people have to put them in their personal bathrooms and they dread it because they're like, oh no, I have to have a grab rail. So how can you make something like that's a supportive product look and feel more premium, and it's actually a value add as opposed to a negative. So it's mostly about the aesthetic improvement of bathroom fixtures across these recent years.
Poor old grab rails, they get a bad rap. But yeah, I totally get the negative connotations of having to put a grab rail in your bathroom. Well, we've got a few questions here from the audience, so I'm going to read those out, and just a shout out to the audience. Keep them coming in. We've got plenty of time to answer any questions that you might have. Don't let me dominate it with all my questions. So number one, can you provide examples of design practices and sanitary ware products that have been proven to effectively reduce the transmission of infectious diseases in healthcare environments?
Yeah, look, sensor taps is a really quick and easy one. Naturally, don't touch stuff. It's a really quick, easy win. So if you've got the opportunity to remove any physical touch points, that's a really quick win. There are the pairing of the tap with the basin and knowing where that tap's water stream hits within the basin is also really important. You don't want that water stream to hit the waste of the basin, because when you hit the water directly in the waste, you can disturb any bacteria that might be within the waste of the basin itself. So you always want your pairing of your tap and your basin to make sure that the stream hits the porcelain or the VC and not the waste. So there's perfect pairings, there's sort of products that work best together, and you can always just do a quick little double check with the CAD files to make sure that the spout's going a little bit longer than the waste. There are products that sort of offset the waste, so we push the waste back a little bit further into the depths of the basin to avoid any chance of that happening. Then, as Gav mentioned throughout his presentation, the antimicrobial surfaces, so the coatings on top of products, so we can inject bacteria, not killing, but it stops the breeding of bacteria, so it means that they can't survive on that surface. We can inject that into the glaze on, say, a toilet, or inside the bowl, or on top of the basin. We can impregnate it into the actual toilet itself, and then we can also any of the plastic products, or the grab rails and the seals within the grab rails, that plastic and within the seals can be also included with the antimicrobial. So basically, where cracks are, where there's little joins and cracks, that's where bacteria can grow, because it's hard to clean in there. So if you get really good seals on those mounting points, and then those mounting points are also backed up with the resistant antimicrobial coating, then it's like a double whammy. So sensor taps, antimicrobial coatings, and also pairing your products well, so you're not disturbing any bacteria that might be growing in errant places.
That is a very comprehensive answer. Thank you, Nick. I wish I was working on this project, because you've given me some great notes.
I was going to say, just on Nick's point, I think important that infection control, if you like, is a system and is not up to any one particular item, but it's how they work together. And I suppose the way that we've tried to tackle that issue is through exactly as per what Nick's been talking about. Firstly, the sensor technology and smart command and smart fixtures, with the data that can come from that to further educate people and have educating processes. And then also looking at the common touch points within the hospital, and how through the antimicrobial protection can we assist in those components. So we can't necessarily avoid people touching everything, hence the handrails and the use of that product within those rails, and also our major toilets used within the healthcare environment. Things like our Care 660 and Care 800 have the antimicrobial protection within them, and these are common toilets used within the hospital environment.
Thanks. That's really interesting. So systems are like working with it. Well, it's about a system of products. It's not just any one product. And
correct.
Work together. Another question from the audience: in terms of regulatory requirements for healthcare environments, what are the key standards and guidelines that architects and designers need to consider when specifying bathroom fixtures in hospitals?
So you've got your sort of standard plumbing standards, AS 3500 and etc. You've got AS 1428, which has some applications when you need an accessible bathroom. So you'd refer to AS 1428.1 2021 standard. That's the most current. And then Gav mentioned a few times throughout the presentation, the Australasian Health Facilities Guidelines. That's really like the focused guidelines around hospital facilities, which does sort of tend to change. So it's always good to keep a tab on that. For example, there was another type C basin. So there was type A, type B, type C. Type C has since been retired, so it was part of the standard, but now it's just type A and type B. So things can change as needs change and as products evolve. So Australasian Health Facilities Guidelines would be probably the most pertinent for hospitals.
And actually, I had a question in regards to type A and type B basins. I was wondering if you could just run us through again, what are the main differences between those two?
Yes, you've got a slide on that, don't you, Gav?
Yep.
In general, basically, a type A is for like medical washdown, like really deep basins where, say, surgeons or someone can really get their elbows in and wash straight up to the elbow, like, so really nice, deep, wide basins, which they're usually mostly just used in sort of clinical sort of washdown areas before procedures, etc. They're very they're large, so you wouldn't put them everywhere. But yeah, all of the features you see up on the screen there, that's what you need a type A to be.
The important thing is with the type A is, the width and the projection to allow, because you need to be able to wash down to your elbows or up to your elbows, depending on which way you look at it. So that space is an important consideration when specifying a type A basin.
Yeah, the type A needs to be minimum 610 mil wide, and then a minimum of 515 projection, basically. So you've got some dimensional requirements that you need to hit. And you could either put it with a bottle trap at the bottom, or you can put a shroud on it. There's no real key reason. You could pick whichever you like, basically, but a shroud is a slightly more clean and neat solution underneath the basin.
And once again, as per Nick said earlier, ensuring that spout location compared to the waste and where the water is hitting. So it's really important. Obviously, the architects go to great lengths and do a fantastic job at specifying the product. It's then about ensuring that on the job site that specification is adhered to, because obviously that's another risk point where a tap swapped in that's just inappropriate for that basin, and it obviously needs to be monitored and managed closely.
Mm-hmm. And what about basin type B in contrast?
Yeah, so that's a bit more of a sort of a general use. So it's still slightly wider and slightly deeper than your sort of average sort of consumer type basin. But yeah, it's kind of used everywhere else in the hospital. It's kind of your standard offering. So it's still pretty deep, and you can still get most of washing sort of right up to your elbow if you really need to. But it's less strict, basically. And it's more of a common use type basin.
It's generally what we might see if we walk down that hospital ward and there's that wash basin on the side wall type scenario where the nurses and or visitors and patients can use. I suppose one of the other main differences is that the tapware can be mounted on the wall or actually on the basin itself. So in terms of a type A, it's not as wide. I think a minimum of 550 wide and a projection of 435 from front to back. So it can be that slightly smaller because it's not that clinical scrub requirement.
Mm-mm. Thank you for outlining that. I'm curious about what type C was, but it's probably superfluous to our conversation now.
Well, it's interesting. The AHFG still talks about type C. Type C, for example, could be used within a patient ensuite. It's I suppose a basin similar to what we might have for what we might call independent living, which would be your basin with an attached shelf and the like. Because the AHFG does talk about, whilst a resident room is not bound by AS 1428 standards, although it may have many of the inclusions, handrails and the like, it does talk about the basin being 1428 compliant, which generally means the basin either has an integrated shelf or there is another shelf in the room accessible for those people, and the basin mixer has a larger care handle for ease of use.
There you go. Another comprehensive answer. Thank you. Another question here. Could you share insights into how the selection of bathroom fixtures and sanitary ware products can help healthcare facilities meet regulatory requirements and improve patient care simultaneously? These are big questions.
I mean, certainly one of them is kind of what we've touched on a little bit in terms of being aware of the AS 1428 standard. And I think it's where it applies and where it doesn't apply equally. We've talked about that whilst it might apply to the basins, what we don't want to do is make a resident room for a standard resident room appear like an AS 1428 room. It's about maintaining patient dignity and the like as well. So it's about understanding that individual room. We talked about there being 3 different types of resident rooms. Is a bariatric care, for example, and the need to ensure that we have a bariatric toilet, you have a bariatric loaded basin, or is it more of your standard room where you have that little bit of a flexibility as a architect and designer to still maintain those functional attributes? Yes, a handrail may be required, but we don't need to go to that AS 1428 length. Nick, did you have anything else to add there?
Yeah, I think I mentioned it a little earlier. It's around, you can tick off those functional requirements, and then you can have products that layer a bit more aesthetic on top, like even a grab rail that are available in multiple colors now. So you can sort of have a matte black accent in the bathroom, or a brushed nickel. It doesn't always have to be stainless steel and clinical looking. Like you can tick the requirements of a standard, but also get some aesthetics in there now. So that's where a lot of the recent trends in bathrooms have sort of been going that way, is how do we get the next step and make people feel like they're less in a hospital.
I think the wonderful thing, sorry about that, just to finish there on those handrails, is the wonderful thing is that we can make it more aesthetic. We can, do a beautiful brushed nickel or a matte black, but underneath that is the antimicrobial coating that people aren't necessarily looking at to help that, once again, the control of bacterial infection. So we can actually serve the 2 important purposes there.
I'm glad that you spoke to that point, because that's what I was wondering, is when you start to add these more aesthetically led finishes to things like handrails, which, by the way, it sounds like the case isn't so bad for the handrail after all, but can you still serve the hygiene requirements? So that's really cool to know. A question on sustainability and maintenance. In terms of long-term sustainability and maintenance, how do these design choices impact the overall cost effectiveness of healthcare facilities? And what products or approaches are known to provide a good balance between prevention and cost?
So an easy double tick is finding products that have long warranties. So hospitals, they might have whole of life expectancies of, say, 25 years, or either 10, 25. So if you can pick a product that has a long warranty, a lot of that hospital life is covered under warranty with a highly warranted product. For example, say, from ongoing maintenance point of view, understanding the products that are specified and what the moving parts are. Example, a sensor tap. The moving part is a solenoid that opens and closes. Every time you turn the tap on, solenoid open, close. So that's the thing that's going to break after X amount of activations. So if through looking at data and having a cloud connected smart product, that this product has been used 250,000 times, it's probably at the end of its life. You can preemptively get a solenoid, send a plumber out, at a quiet period, swap it out, and then you've extended the life of that product, as opposed to waiting for something to break and then shutting down a patient's room and having an emergency call out. Like, you can cut your you can be more proactive in your maintenance versus reactive, and save money that way, just by a deeper understanding of how products are being used within the space. But yeah, what are the moving parts? Making sure the hospital has those parts on hand if they need them. So they'll have on-site maintenance staff. So it's always a good idea for them to hold some spare parts on the site. It could be, for example, some of these taps, just the cartridge that sits in the handle, rather than waiting for that to get sent from a plumbing store out to the hospital, then for the plumber to install it. If you know that you've got those taps fitted throughout the hospital, just have some of those cartridges on hand, and that can help you even just from emergency call out versus bathroom uptime as well. I hope that kind of answers the question.
I found it was a fantastic question, and I think quite an interesting one in terms of, Obviously, projects and new developments will always have that cost factor that needs to be managed. We can't get away from it. It's part of the new build. How do we compare that to the cost of bringing in, maintenance on an ad hoc basis through, I suppose, purchasing or specifying perhaps poorer product, cheaper product? And even then, particularly in the public space, what are the political costs of rooms and so forth being down due to fixtures and fittings that potentially shouldn't have been installed and were installed? So I think there's a range of costs here to be looked at. I think, the smart command technology will become more and more prevalent within this space, and the data-driven aspect as we continue to evolve and derive more data out of it. It's not only about, okay, are these products towards the end of their lifespan, but how do those products in that particular toilet compare to the other products? Perhaps you've got taps that are hardly ever used because of their placement. You start to understand usage patterns within a hospital, and it may just be the case that their own internal maintenance team can swap taps over and maintain a longer lifespan for their product. So it's not necessarily, just understanding when do we need to replace things, but how can we absolutely get the maximum lifespan out of these products? And I think there's long-term cost savings there that, perhaps this technology is still too young to completely understand what those benefits will be. But I think in time, they will become more and more evident.
I think another large cost from a plumbing point of view for ongoing maintenance is every hospital needs to have a thermostatic mixing valve installed, and that is a serviceable item and needs to be serviced every 12 months. That's basically the thing that makes sure that the water temperature comes out at the right temperature and doesn't scald people. So it's really important that there's a regular maintenance schedule in place for plumbers to go and inspect the TMV and also replace the cartridge if need be. So that's a really costly exercise. And I guess the next frontier is kind of, how do we take something that's slightly manual at the moment and make it a bit more smart, and something that doesn't require as much manual intervention, but can still protect users in the same way that a thermostatic mixing valve does. So that's something that sort of we're looking at as the next big cost saving for hospitals.
And just a couple of more quick questions before we're out of time. Are there any specific technologies or innovations in bathroom fixtures and sanitary ware products that are particularly promising or preventing the spread of HAIs in healthcare settings?
So the antimicrobial one was a big tick. That's an easy one. An easy way as well, and another byproduct of having a smart product in there, is that you can have pre-programmed hygiene flushing going on. So stagnant water is the enemy. Bacteria grows on stagnant water. So if you can, if we can pre-program that if that product hasn't been used in 12 hours, 24 hours, whatever, it will flush. That'll do a little purge and it will push the water through. So you don't have water stagnating, and that's potential places where you would get bacterial growth. Some stuff could be really simple, where automatic open-close toilet seats. When you flush a toilet, bacteria can come out of the pan and out into the room. But if you had a toilet that had an automatic close and then you flushed, you can potentially stop a whole bunch of bacteria getting into the space. So there's some clever little things that you can do through technology to reduce the spread and chance of bacterial spread. An easy one, touchless products, again, on touch points that are heavy bacteria spots, like a toilet flush panel, a sensor tap, even just having the coating or a hydrophobic coatings on some products so that stuff doesn't stick to them. That's another really easy, quick win. Like technology in terms of both smart stuff, but also easy wins, like, but my antimicrobial coatings is probably the best technology that you can employ with bathroom fixtures.
Once again, I think it's a bit of a system there. If you integrate the sensor tap with the laminar flow aerator with the correct basin such that you don't getting splashback, you are, we're not just talking about one item there. You need to tick several boxes. So, once again, I keep coming back to that. The design and the integration of those products, I think is vitally important.
It's a great point there, Gavin. And just one more question before we're out of time from our audience. Is there any such thing as a non-marking pan?
We've got the closest thing too.
And also, I mean, in things stain over time. It's just it's a matter of time, basically. The cleaning products that are used is also pretty important, and how the cleaners go about their daily operations. So in hospitals, they tend to use really harsh chemicals. You want to basically not bleach, but close to it, just completely kill everything that might be in a hospital when they're cleaning. You'd want to dilute that. That's what we recommend to cleaning staff. There's no need to really go crazy with the really harsh chemicals. So if you dilute the cleaning solutions and use non-abrasive cleaning materials, like a cloth, for example, that'll do the job. You don't need to absolutely cram harsh chemicals with abrasive materials. That'll ruin the longevity of the say the vitreous china, for example, and then you'll get staining and whatnot a lot faster. So it is important to for the cleaners to be on the same journey.
I think, look, we had a bit of a laugh there at the start, but Caroma, the one thing Caroma is known for, and I think it's particularly pertinent in hospitals where there's a lot of medication being used and the like, and potentially a lot of toilet paper that needs to be, flushed and removed. Caroma is known for having a larger sump, a larger collection area, if you like, for the waste, and some inferior products actually have the back of we're getting into the nitty gritty here, but the back of the bowl is on an angle, which isn't great in terms of allowing the waste to just simply go into the bottom of the water and the sump to be removed by the flushing mechanism. So, design certainly does have a place to play in helping to eliminate marking or reduce the level of marking, absolutely. But you're right, the toilets and our vitreous china and the glaze, it's designed that it should not need harsh chemicals to clean. In fact, that is counterproductive in the long term. It's about regular flushing. So, if we're in situations where, patients aren't able to flush, whether it be, sensor operated or automatic flushing systems that assist in the removal of the waste. The longer waste sits in these areas, the heavier the marking.
Thank you. Your answer has brought us up to almost the hour that we had. And I'm going to wrap up our session. Thank you so much, Gavin and Nick. You're obviously naturally expert in this area, and it's been really interesting learning about it. Thank you as well to our audience for your attendance and your attention. Much appreciated. Thanks for joining us for CPD Live. Hope you all have a wonderful afternoon.
Thanks for having us.
Thanks for your time and the opportunity. Appreciate it. Thanks, guys.